There's a window in your home that leaks, not dramatically, not with water running down the wall, but quietly, invisibly, expensively. Cold air finding the gap between the glass and the frame. Warm air escaping through a seal that dried out and cracked years ago. Your heating system running longer than it should. Your energy bill climbing every winter. Your home losing warmth through a failure so simple that the fix has been known since before your grandparents were born. The fix costs $1. It is a compound that has been used to seal wooden window frames since the 1700s. It outlasts every synthetic caulk on the market. It never fully hardens, which means it never cracks, which means it never fails the way every petroleum-based sealant you have ever applied eventually fails. It bonds chemically to both wood and glass. It remains flexible through decades of thermal expansion and contraction. And it has been entirely absent from every hardware store window repair guide, every energy efficiency checklist, and every contractor recommendation for the last 60 years. The reason it disappeared is the same reason it had to disappear. The window replacement industry in the United States alone generates over $40 billion in annual revenue. The single most effective argument a window salesperson makes is that your old windows are beyond repair. A $1 compound that restores old window seals permanently is not a product opportunity for that industry. It is an existential threat to its entire sales model. The compound is linseed oil putty, a combination of raw linseed oil and powdered calcium carbonate in a ratio that has remained essentially unchanged since the first glaziers in 17th century England learned to hold glass in wooden frames with something that would last. Welcome to $1 Miracle. This is where we open the vaults the window industry hoped you would never find. If this kind of knowledge matters to you, subscribe now and hit the bell. Because what I am about to show you will change how you look at every old window in your home, and every salesperson who told you those windows needed to be replaced. Let me take you back to where this all begins, not to a laboratory, but to a glassmaker's workshop in the Dutch Republic, sometime in the early 17th century. The Dutch in the 1600s were among the most sophisticated builders in the world. Glass was expensive, difficult to produce in large sheets, and irreplaceable if broken. Holding it securely in wooden window frames was a problem that required a solution more reliable than simple friction alone. The glaziers of the Dutch Republic developed a compound from two abundantly available materials: linseed oil, pressed from the seeds of the flax plant and used across northern Europe for everything from paint to rope preservation, and whiting, powdered chalk used as a filler in a dozen different trades. Mixed together, these two materials produced something that behaved unlike any other substance available to builders at the time. Workable when fresh, soft enough to be pressed into the joint between glass and wood, and shaped with a knife into a clean angled bead. It skinned over slowly as the linseed oil oxidized on contact with air. And beneath that surface skin, it never fully hardened. The core remained semi-plastic, perpetually flexible, moving with the wood as it expanded and contracted through seasonal humidity changes without cracking, without separating from the surfaces it bonded to, without creating the gap that lets cold air through. This combination produced a sealant that glaziers across Europe used for 300 years. The windows of Georgian townhouses in London, of federal-style buildings in Boston, of plantation houses in Virginia. Every pane of glass and every wooden frame in every building constructed before the 20th century was held in place by variations of the same compound. Those windows, in the buildings that have survived, still hold their glass. The putty applied by a competent glazier in 1820 is still in place in 2024, in windows that have never been touched since original installation. Now let me show you exactly why linseed oil putty works where modern synthetic sealants fail. Because understanding this will make every tube of latex caulk you have ever applied look like exactly what it is: a recurring revenue product masquerading as a permanent fix. Latex caulk cures by evaporation. The water or solvent carrier leaves the material as vapor during curing. As it leaves, the caulk shrinks, typically by 10 to 15% of its original volume. In a window glazing joint exposed to direct sunlight, rain, freezing temperatures, and the constant thermal movement of wood frames expanding and contracting with every seasonal change, this shrinkage creates microscopic tension in the cured material. The result, over 5 to 7 years in most climates, is cracking, separation, and the gap that lets cold air through. Every 5 to 7 years, the latex caulk fails. Every 5 to 7 years, the homeowner removes the failed material and applies fresh caulk. The product is not designed to last longer than that. A product designed to last longer would be purchased less frequently. Linseed oil putty does not shrink on curing. The polymerization of linseed oil is an addition reaction. Chains grow, but volume is maintained. The putty that fills the joint after application is the same volume after curing as it was when applied. It does not pull away from the glass. It does not crack at the corners. Because it never fully hardens, it absorbs the thermal movement of the frame by deforming slightly. The same microscopic flexibility that makes it impossible to crack. A properly applied linseed oil putty joint has a service life measured not in years, but in decades. Well-applied traditional glazing compound on protected wooden frames regularly lasts 40 to 60 years before requiring renewal. Now here is where the story becomes very uncomfortable for the window industry. By the 1930s, glazing compound was a standard product stocked in every hardware store. Every homeowner who had a window with a cracked or missing bead knew that you bought a can, a putty knife, in an afternoon, and the window was restored. The knowledge was simply part of what a competent homeowner knew how to do. Then, in 1952, the first mass-market aluminum replacement window was introduced to the American consumer market. By 1975, an entire industry had organized itself around a single proposition that old windows were inferior products that should be discarded and replaced with new factory-manufactured units. Old windows are drafty. Old windows are inefficient. New windows are thermally superior. New windows are maintenance-free. Most of these claims were presented without the context that would allow a homeowner to evaluate them honestly. Old windows with failed putty are drafty, but restored old windows with fresh glazing compound are not. The energy payback period for window replacement, the time it takes for energy savings to recover the cost of replacement windows, has been calculated by independent researchers at between 25 and 100 years, depending on climate and energy prices. Most replacement windows carry a warranty of 20 years. The maintenance knowledge that would have prevented the replacement conversation was systematically removed from the consumer's awareness over the same period. By the 1980s, glazing compound had shrunk from a prominently stocked product to a specialty item. The tube of synthetic latex caulk, a product designed to be reapplied every 5 to 10 years, a product that generates recurring purchase, had taken its place on the shelf. The technique for reapplying glazing compound disappeared from the mainstream home improvement conversation at exactly the moment it needed to be replaced by the replacement conversation. A preservation architect working with historic building stock in New England documented the performance of traditionally glazed wooden windows against vinyl replacement windows in a comparative study published through the National Trust for Historic Preservation in 2012. The study followed 12 pairs of matched windows over a 10-year period. At the 10-year mark, the restored traditional windows showed no glazing failure in any of the 12 pairs. The vinyl replacement windows showed seal failure, evidenced by fogging between the panes in 4 of 12 pairs. The thermal performance difference between the restored single-pane windows fitted with interior storm panels and the double-pane replacements was measured at less than 8%. The cost difference between restoration and replacement was approximately $4,300 per window pair, in favor of restoration. $4,300 per window, saved by a can of glazing compound, a putty knife, in an afternoon. Here is exactly what to do. This is the part that every window restoration craftsperson knows, and that the replacement industry has spent 40 years making sure you would never learn. Go to any hardware store and purchase a can of traditional oil-based glazing compound. It is still manufactured and still sold. It has simply been moved to a less prominent location as latex caulk took the primary shelf position. Look for products labeled oil-based glazing compound. A quart can costs between $5 and $8 and is sufficient to reglaze every window in an average home. You will also need a putty knife costing $2 to $3 and a stiff brush for surface preparation. Begin with surface preparation. Use the putty knife to remove all existing failed glazing material from the joint between the glass and the frame. Work carefully at the corners. This is where failure typically begins. Clean the bare wood with a stiff brush to remove dust and loose paint. If the wood is bare, apply a thin coat of raw linseed oil to the wood surface and allow it to soak in for 30 minutes before applying new compound. This prevents the dry wood from drawing oil out of the fresh compound too rapidly, which causes premature hardening and cracking. Take a small amount of glazing compound from the can and work it briefly in your hands to warm it and improve workability. Roll it into a rope roughly the diameter of a pencil. Press this rope firmly into the joint between the glass and the wood frame, working from corner to corner along each side of the pane. Use the putty knife, held at approximately 45 degrees to the glass surface, to bevel the compound into a clean, angled bead, sloping away from the glass at a consistent angle that sheds water away from the joint. The bevel is critical. A flat or concave glazing bead holds water in the joint during rain. The traditional 45-degree bevel sheds water by gravity. It is not an aesthetic convention. It is a functional design that determines whether the repair lasts 5 years or 50. Allow the fresh compound to skin over for 3 to 5 days before painting. Traditional glazing compound must be painted to achieve its full service life. The paint seals the surface from oxygen, preventing the outer layer from becoming brittle over time. Use an oil-based paint if possible. Extend the paint slightly onto the glass surface by 2 to 3 millimeters to create a continuous seal between the paint film, the glazing compound, and the glass. This overlap, called the paint line, is the final seal that prevents water from finding the glass compound junction. Once painted, the restored window requires no further attention for decades. The window your contractor told you needed to be replaced can, with this treatment, provide another 30 to 50 years of service without further intervention. For windows with wooden frames that have also developed rot at the corners, a common problem where water has been sitting in a failed glazing joint for years, the repair is still achievable without replacement. Consolidate the softened wood with a penetrating epoxy consolidant, available at any good hardware store for under $10. Once cured, the consolidated wood is harder than the original material and can be shaped with a chisel or knife back to its original profile. Fill any remaining voids with epoxy wood filler. Prime the repaired area with oil-based primer. Then apply fresh glazing compound as described above. A window frame that a contractor dismissed as beyond repair can be structurally restored in an afternoon and will outlast a vinyl replacement unit by decades. The total material cost for a corner repair of this kind is rarely more than $15. Let me leave you with something that no window manufacturer can patent and no replacement salesperson can argue away. Wood lasts. Wood, properly maintained, outlasts every synthetic material the construction industry was ever offered as its replacement. The wooden windows of Georgian London, of Federal Boston, of Colonial Williamsburg. These windows are still in service, still holding glass, still sealing against the weather because the people who built them used materials designed for permanence rather than for recurring replacement. Linseed oil putty is one of those materials. It is not a primitive solution waiting to be superseded by modern chemistry. It is a solution so well matched to the problem it solves that 300 years of synthetic alternatives have failed to improve on its fundamental performance. The window replacement industry did not win by producing a better product. It won by making you forget that restoration was possible, by removing the knowledge of glazing compound from the mainstream home improvement conversation at exactly the moment it needed to be replaced by the replacement conversation. By turning a maintenance task that costs $20 in an afternoon into a capital expenditure that costs thousands and generates a commission. But linseed oil does not know about commission structures. The chemistry that has held glass and wood for 300 years works the same way today as it did in a Dutch glazier's workshop in 1650. The wood in your window frames has not changed. The glass has not changed. The thermal physics of a well-sealed joint have not changed. What changed was what you were told was possible. And what you were told was possible was determined entirely by what was profitable for the people doing the telling. Now someone is telling you something different. If this vault changed how you look at the windows in your home, subscribe and share this now. Every share keeps $1 miracle digging in the places the construction industry hoped we would never look. The next vault opens soon, and what is inside has been sold to you in a branded bottle for $15 when the raw material costs $1 and does the job 3 times better.